the statistics process, and here it is spelled in Greek. You start with a research topic, and then you have a research question, which is the fundamental initiator of the research, okay? It's like a question that has to be answered by first collecting data. Okay, so you must have a research question for you to start the research, okay? And there'll be variability in that data when you collect that data to answer the research question, okay? So the research question sets out to answer the research question, okay? The research project sets out to answer the research question. Bear that in mind, that's very important. The research project, that whole trajectory, okay, sets out to answer the research question. But before you collect data, you can propose a possible answer to the research question. They call that a hypothesis. A hypothesis is a supposition or proposed explanation or statement, if you will, that is made on the basis of limited evidence as a starting point for further investigation. In other words, it is a possible answer to the research question with little or no empirical evidence. So you propose an answer without having collected the data yet, but you have to collect the data. You have to organize the data, represent the data, analyze the data, and then you're coming back now, round circle, to prove or disprove that hypothesis, all with the intention to answer that research question. Okay, now, remember we said the research question is the fundamental initiator of the research. It is the one that should be answered by first collecting data, and there'll be variability in that data. The research project sets out to answer the research question. Now, the hypothesis is a supposed or proposed explanation, a statement or sentence, if you will, that is made on limited evidence, okay, as a starting point for further investigation. In other words, it is possible to answer the research question with limited or no empirical evidence, okay? So just bear that in mind, okay? The hypothesis is a possible answer with little or no empirical evidence. Okay, so just keep that in mind. All right. Now, seeing that the hypothesis now is a possible answer to the research question with no empirical evidence, we're not really sure if that hypothesis is the correct answer. Okay, so data have to be collected, organized, represented, analyzed, and then that hypothesis has to be tested, and this is called hypothesis testing. It is the theory, method, and practice of testing a hypothesis. Remember, we said a hypothesis is a proposed answer of the research question based on limited evidence. Okay, hence data has to be collected in order to test its veracity or truthfulness. Okay, so it's like a sentence, it's like a possible answer to the research question, but it has to be tested because we're not sure if it is correct or not using empirical data, okay, that was collected. Okay, so always bear that in mind with regards to the hypothesis. Okay, it has to be tested because it needs data to back it up, and this is called hypothesis testing. Okay, now there are different approaches for the hypothesis testing. You have the critical value approach or the classical approach. Then you have what you call the p-value approach, and you have what you call the p-value approach using Excel or SPSS or Minitab or other, you know, stat graphics or the statistical programs. Okay, so the hypothesis tests being studied, there are different types of hypothesis tests. So the ones that are being studied here is called the z-test for mean. All right, testing a claim made by someone regarding the mean of a variable, and 3 types of chi-square or goodness of fit. That is a Greek symbol, and this one is the Greek symbol mu for mean and chi-square for that type of test. 3 versions only: chi-square test for variation, chi-square test for randomness, and chi-square test for independence. Okay, these are the 4 types of hypotheses we're going to study. Okay, now we're going to talk about the critical value or classical approach. Okay, first, the hypothesis statements for z-test for mean. So you first have to state a pair of hypotheses. Someone will make a verbal statement regarding the mean of a variable. The statement will be said in a verbal form. To begin the z-test for mean, the statement will be written in mathematical form. So for the z-test for mean, verbal form have to be converted to mathematical form. Okay. So the first step in applying a z-test forming or chi-square test using the critical value approach is to state a pair of hypotheses. One is called the null and one is called the alternative. Okay, for the z-test forming, the null will have those signs there, less than or equal to, more than or equal to, or equal to. And for the alternative, it will have those signs there, less than, more than, or not equal. So that is the hypothesis for the z-test for mean, because that's the first step. And here now is the table to facilitate the conversion of the word hypothesis to symbolic form, and that is for the z-test for mean alone, all right, in this course. So your worded hypothesis will be converted to symbolic form using this table for the z-test for mean. For the chi-square test now, the hypothesis, the HO and the HA, the null and the alternative, will remain in worded form. So this will be the hypothesis for the chi-square test for variation. This will be the pair of hypotheses for the chi-square test for randomness, and this will be the pair of hypotheses for the chi-square test for independence. So for the chi-square test, the hypotheses, here they are, the pair will be remaining in worded form. So that's the first step, a pair of hypotheses. Okay, for the z-test, word to symbols, but for the chi-square, it remains in words. Second step, you have to sketch a curve. For the z-test, it will be a normal curve. For the chi-square, it will be a curve skewed to the right. Third step, a critical region has to be obtained. Okay, bear in mind, we call that the critical region approach. For the z-test, you can have three different situations. You can have a right tail, a left tail, or a two tail. The tail will depend on the alternative symbol. So if the symbol is pointing to the right, then you have a right tail. If the symbol or the alternative is pointing to the left, you have a left tail. If the symbol for the alternative is not equal, then you have a two tail. That's what the z-test for mean. But for the chi-square, it will always be to the right. Okay, bear that in mind. The critical region will always be on the right for the chi-square. Okay. The fourth step is to place what you call a critical value on the critical point. The critical point is right there in that corner there. The boundary between the shaded and the non-shaded. That's where you have the critical point. Okay. So you have to put a value there. The critical value coming on the critical point. Okay. That will be in the fourth step. On the fifth step, you have to calculate what you call a test statistic, because it's you're testing hypothesis. So you have to calculate the test statistic. Here's the formula for the z-test statistic, and here's the formula for the chi-square. Remember, we have three versions of the chi-square, but this formula will be serving for all three of them. That's a constant formula for the three versions of the chi-square. And the z-test statistic, there's the formula for it. Okay, that's the fifth step. Now the sixth step, now that test statistic, you have to go and you have to place it on the curve. Remember the curve that was drawn in step 2, and the critical region was shaded, and you have a critical value on a critical point. Then you have to go back to that curve and put the test statistic. Okay, that will be in step 6. Okay, and in step 7, then you have to decide whether to reject the null. If the test statistic is in the rejection region, you reject the null. If the test statistic is not in the rejection region, you do not reject the null. So it's all about the test statistic to reject or not. There are two types of errors that can be made. Okay, type 1 and type 2 error. So we'll take a look, remember that. Okay, but just remember now, the decision time is based on where the test statistic landed. So if the test statistic landed in the unshaded region, you do not reject the null. But if it lands in the shaded region, then you reject the null. Okay, so that's the importance of the rejection region shaded in step 3, and the critical value is on the critical point. So based on your test statistic value, you will know where to put the test statistic, because the critical value will serve as a guide, okay, as to where to put the test statistic. And if the test statistics land in the unshaded region, you do not reject the null. Remember, you started with a pair of hypotheses from the beginning, okay? The null and the alternative, okay? The null and the alternative. Okay, so if the test statistics land in the critical region, then you reject the null. That is in step 7. And in step 8, now we conclude. If the null is rejected, remember you started with 2 pairs. You started with a pair of statements, 2 of them. So if you reject the null, then the alternative is the conclusion. If you do not reject the null, then the null itself is the conclusion. Always remember that you will start the test with 2 statements, the null and the alternative. After the test is done, only one will be the conclusion. Write out the conclusion in verbal form. So that's the critical value approach. Now you have the p-value approach. The p-value approach is the beginning is the same. You start with a pair of hypotheses. Then you calculate the test statistics, step 2. Then you use the test statistic to obtain what you call a p-value, okay? And then you use that p-value now in step 4 to compare to what you call a significance level, okay? And then based on that comparison, you decide to reject or not reject the null. You reject the null if the p-value is less than significance level, and you do not reject the null if the p-value is greater than the significance level. There are 2 types of error that can be made. And conclusion is basically the same. If you reject the null, then the alternative is the conclusion. If you do not reject the null, then the null itself is the conclusion, okay? And then you have the p-value approach now using Excel or SPSS. State a pair of hypotheses. You must begin by stating a pair of hypotheses. Then you input the data in Excel, okay, or whatever program you're using, and you process, that program will process the data and to produce the respective output. Identify the p-value from that output, and then you use that p-value now and compare with your significance level. And then based on the comparison, you reject the null if the p-value is less than significance level. Remember, you get the p-value from the calculation from the Excel, you understand? But you start with a significance level, and if the p-value is greater than the significance level, you do not reject the null. And if you reject the null, then the alternative is the conclusion. If you do not reject the null, then the null itself is the conclusion. Okay,